Today, we're going to look at the switch statement, something called the conditional operator, and the do while loop. So that will only leave us with the for loop as the basic statement of control of flow that we have to deal with. So after today, you should be able to implement the switch statement, understand when and here's the thing is that the difference between the while loop and the do while loop can be subtle, but it's kind of an important one. And I can just tell you briefly that it's a while loop is executed 0 or more times based on whether the condition is true or false. The do while, as we will see, because the condition is tested after the block of statements is executed 1 or more times. In other words, the do while loop is always executed once and maybe more, whereas the while loop will only be executed 0 times if the initial condition is false. But let's move on to the switch statement first. What the switch statement is kind of an antidote to a long string of else-if statements. What you may have noticed in writing some of the complicated conditions is that in certain circumstances, if I have many conditions that could be possible, then in a certain constrained set of circumstances, I can replace that with a switch statement, which makes it a little clearer what is going on. So the idea is that the switch statement evaluates an expression, and then it attempts to match that result to one of a number of possible cases. Each possible case is a possible value and then a list of statements that will be executed if that value happens to be the result of the expression. And the idea is that the flow of control moves from the evaluation of the expression to the first case that matches. And then it keeps executing. Now there's a little bit of a gotcha in terms of using the break statement. And the rule of thumb is always use a break in it, as we'll see. But there are rare occasions where it might not be necessary. However, that should generally be the default because there are unintended consequences if you don't use the break. All right, come on. Okay, so here's how it works, is that you have this expression. And remember, an expression can be a single value. Many times it simply is, but it can be any expression. And then you have a series of case statements which list the possible values. So in this particular case, they're saying, supposing the expression matches value 2, then it jumps right over and executes this list of statements here. Now, and here's where kind of the tricky part comes in. If you don't have a break statement, then control actually keeps executing further down, regardless of the case. That's why the break should always be the default, because it's only in rare cases that you don't need the break. And you say often, most of the time, mostly, it's used as the last statement in each of the case statement. So what the break does is putting a break causes you to go all the way to the end of the switch and then execute following it. If it's not used, it'll continue into the next case. And that's where these little gotchas come in. So in almost all cases, we only have one case that we want to execute. That's why the break should almost always be used. Okay, so here's, again, a typical example. And I'll show you kind of a similar one. So here, supposing the only possibilities for this option are a character. So for this to work properly, option would have to have been defined as a char. So characters work, and we'll see a list of things that. Okay, so and somewhere character has been defined, or option has been defined as character. And in this case, option is only A, B, the character is B or C. Okay, so this is an example, and then notice that there's a break here. So what is this doing? In the case where the option variable can only be the characters A, B, or C, this is this presumably would be embedded in some kind of loop. And this would be counting the number of occurrences of each of the possible letters. And so it should be clear that if you leave the break out, for example, supposing we leave the break out for the case A, then what will happen is you will increment the count for A, but then control will immediately go to the count for B. So if option is the character A, then it will count both A and B if we leave the break out. And that's why we don't want to do that. Now, there's an optional default case, and what I will encourage very strongly and almost insist on is that you always have a default, because you never know when something will kind of go awry. So for example, what would happen if a character other than capital A, B, or C is the value of the option variable here? Well, in this case, everything will just be skipped over, and the user or whoever's running the program will have no idea. In other words, it may be that some bad data got in, a character that was other than the three that they were insisting on here. So typically you want to have a default statement. We'll see that when I show the example, that will basically flag it and say, oh, option can only be capital A, B, or C. And that's what would have been better style for that. So if there's no default and nothing matches, then you just fall all the way through. Okay, now other languages can be a little bit more flexible. Actually, when Java first had this, introduced this, the only possibilities were integers and characters. And then people said, well, you know, we want enums too. So they added that, and then they said, well, we want strings. So the only possible expression value, the only possible things you can use for a case can be integers, characters, enums, or strings. We can't use it with floating point values because the idea is that you want absolute equality. And as we showed previously, equality with floating point values is not something that you really want to do. Okay, so the book's example, we had a numerical grade from 0 to 100. They divided into categories by dividing by 10, and that took the grade from 0 to 100 to 0 to 10. And then the switch statement, okay, so now notice the category is an int. Again, and then, okay, we look at the cases. So here we have perfect, we have well done, above average, average, below average. And then here's a good example of the default. Okay, so the possible values are 0 to 10. Those are the possible values. And in this particular case, we only want to look at 6 through 10. And if it's anything else, in other words, the default will get executed if it's 0 through 5. Okay, so this is a good exemplar of why you almost always want to have a default. Okay, so see, what was my, okay, so here's another example in the class code. And I'm using it with enum values and combining some of the other things that that we were basically doing. So this, don't worry about this statement for now, because that has to do with this conditional operator that we'll talk about. But remember, we now know how to read in text from a file. So I have a text file that consists of a random set of strings, which could indicate a playing card. But remember, these are strings. These aren't actual playing cards. So what I want to do is I want to count the suits. So count in this. What I did was I randomly generated playing cards and then printed them out to this cards.txt file. And so I'm going to read that in with the scanner. I'm going to use the delimiter of a new line, because I want to use the has next and next rather than the next slide. I could have done the other. But what I want to do is, in this randomly generated file of strings that could represent cards, I want to count the number of each suit. Okay, so this is a good example of how you could use this with if statements, but a switch statement is much cleaner. Okay, so now I'm using a while loop, okay, to reinforce that. So I get the next card, which would be the next line here. So it's not really it's not a playing card, it's actually just a string. And for that string, now there's actually a cleaner way to do this using a property of strings that we'll talk about later in the course. But for now, the way that we've been processing a string is to put a scanner on it and then process the tokens. So what this is now I'm taking that card, I'm adding a scanner to it, and then each card is going to have a suit or a value of suit. Okay, so there are going to be 3 pieces to every single one of these. So I want to get the next value, and I don't want to do anything with it. The next token is going to be of, and I don't want to deal with that. It's the suit that I want. So I'm going to get the suit string, and now I want to, now I could have had the switch based upon the string, But because I wanted to illustrate it using enums, I'm going to take that suit string and assume that it actually is going to give me a suit enum. Remember, the suit enum was this. We have clubs, diamonds, hearts, and spades. Those are the only possibilities. Okay, so now I'm going to switch on the suit. And remember, what I'm doing is similar to the example with the characters. I'm counting the number of clubs, the number of diamonds, number of hearts, number of spades. And as I said, this is all wrapped up in a while loop that's processing every one of these lines. So what is this doing? This is counting the number in each suit in this set of randomly generated cards. Now, in this particular case, what will happen if I don't have the right string for a suit? It's actually going to choke right here. So strictly speaking, this default is not totally necessary. But again, now supposing you were given this task, how would you do it if you didn't have a switch? Well, you could do it. You would have to say, if the suit is equal to clubs, then count increment clubs, else if the suit is diamonds, increment diamonds, else if the suit is hearts, increment hearts, else if it's spade, increment spade, else error. You could do it that way, but that's a big string of else ifs. And in this particular case, the intent of the programmer is much clearer using the switch statement. In other words, here it's absolutely clear to anybody reading this what we're doing. Now you see the string of else ifs, you could figure it out, but it's just clunky. It's not very, it just is ineffective. Now, if for some reason you prefer the string of else ifs, I'm not going to quibble with that. But having something like the suit available to you is a very useful thing. So if I run this, let's see, run that. Okay, so it counted 10 clubs, 8 diamonds, 6 hearts, and 6 spades. Okay, so that's the switch statement. Okay, the conditional operator. Now this is again, it's a little bit of syntactic sugar, but in certain circumstances it's useful because it presents a situation where you have two very short options based upon a condition. It's strictly speaking not necessary because you can replace it with an if condition, expression 1, else condition 2. Else expression 2, I mean. But this is just a very compact way of representing that. So the syntax is I have a Boolean condition, and the condition is just any expression which evaluates to true or false, any Boolean expression, and then the question mark. So if it's true, then I get this, and then followed by a colon, and if it's false, I use the expression. So the value of the whole thing is whichever of these two expressions is formed. So it's just a shorthand way of representing this. And again, it's a bit of syntactic sugar. However, in many circumstances, it conveys the intent a lot cleaner. So here's an example where I have two numbers. Come on, I have two numbers, and I want the larger one. So here's the Boolean condition. And I like how they put the parentheses in. The parentheses are actually not necessary, but in this case are recommended, because without the parentheses, it relies on the operator precedence. So the parentheses are very good here. And if num1 is bigger, then the value of the expression is num1. And if it's false, then it's num2. It's sometimes called a ternary operator. You don't have to remember that, but it has 3 operands. But so here's another example where you this is sometimes useful where you have singular versus plural. So if count is 1, then it puts in the singular dime. And if count is not bigger than 1, then it puts in the plural. Okay, so their little quick check is, so if val less than 1, then it's not greater than 10, greater than 10. So, for things like this, what the key is to look at the common pieces. So I have 2 pieces that are common and just one which is different. And so a kind of ternary thing would be to say, okay, we take the common, it is, and then this whole expression is going to be either the string not or the empty string, and then greater than 10. So which one is, it's not that one is better than the other. There are 2 different ways of doing the same thing. So okay, before we get to that, just something that I was doing with here, and this is actually one of the main use cases for me, and that is that when I'm reading a file, I will often try to get that file name from the command line. Remember, since the beginning, we've seen this string array args thing. And what that is those are the things that come from the command line. You say, well, what the heck is the command line? Well, the command line is something that if we were running this using the command prompt or the bash terminal, if you're on a Mac or Linux, then you would execute a Java program from the command line. You say Java, and then give the name of this file, and then followed by optional parameters. And those parameters are passed into main through this string, through this string array. Now, we're going to talk about arrays tomorrow, but each array knows what length it is. So here's the thing, is that if there are no arguments on the command line, then the length of this array is 0. But if there are, then in this particular case, I want the name of the input file to be what I read in. Now, if I want to run the program without having to type, to give an explicit file, I have a default one. In this particular case, I had this cards.txt file that I'd created. And so if I don't specify anything else, then that's the one that I'll use. So the idea is that with this, I'm using this ternary or conditional statement to get the input file name. So here's another example where where I'm using that. Okay, so it's the conditional with default. So again, I use the input file name. So here I'm reading in a text file. And here are just some of the things that when you're getting stuff like this, if I'm trying to find a file on the command line from something that's the user types in, well, first of all, there are two possibilities. The user could fat finger some file that doesn't exist, in which case there's no point to executing the program at all. So if that file isn't found, then I'm going to say, okay, hey, you couldn't find the file and return. So don't even be in a situation where you're going to get a file not found exception. So if I find the file though, then I say, okay, I'm going to use this file. And now here I wanted to give another example of using an array list. So what I want to do is I want to read every line of this file and print out the first 100 lines of it. And then I'm going to specify that with a static final int called max output. Because if what I wanted, sometimes you just want to kind of peek at the first bit of a file. And this is another use of the array list. So here's my scanner for the input file. And then I'm just going to kind of read each line and add it to this array list. Okay, so when I'm done, the array list should have actually everything in the file. This is going to slurp up the entire file. And notice that I have to catch a file not found exception. That came from the scanner's constructor. So when it gets here, the input file as a file still is something which may or may not exist. And so I have to catch that file not found exception, or I could throw it the way the book does, but it's usually better style to catch exceptions rather than just kind of rethrow them. Okay, so now I can tell you how many lines there are by the size of that array. And then I'm going to print either the minimum of the 100 or whatever this value is, or the size. So if my size is like less than 100, then that's how many I'll print. And if the size is greater than 100, then that's what I'm going to print there. So here's how I can do that. I only want to print the first 100 ones. And because we haven't done the for loop yet, I could have done it using the for loop, but instead I'll use the while loop because that's what we know at this point. So I'm going to count the lines here, define an iterator as we've discussed previously. And then here's my condition: while the iterator has next and the line count is less than or equal to the max output. So this will only print the first 100 lines if it's greater than 100, or as many as there are. So again, look at this Boolean expression. So if as long as has next is true and line count is less than the maximum output, then it keeps going. If I run out of lines, then has next is going to be false, because this is an and, then the whole thing will be false. On the other hand, if I hit max output first, then this will be false, because as soon as it hits 101, then that will happen. Okay, so this is actually a file that I downloaded from Project Gutenberg. It's, I forget which one it is. We'll find out when I run it. Okay, so we use this file, and it had 7,000 blah, blah, blah lines. I'm only printing 100 of them. And this was the Project Gutenberg book of Frankenstein. And there's a bit of front matter here. where they talk about here's the ebook for Project Gutenberg. Here's the title, the author, release date of this is the release date of the ebook, not of the original one, which was back in the 1900s, and who they were. And then, okay, so it lists all these contents, and then it starts with the text of the document itself. Okay, so that was using the defaults. Now, how do you, what if we don't want what if I wanted to read something else? Now that's where using the command line. Now, how can I use the command line in NetBeans? Well, since you asked, I will tell you. So if you look up in the toolbar for NetBeans, you will see this, which usually will say something like default config. But if you drop it down and say select customize, then what you can do is you can create a number of different run scenarios. Okay, so here the default one was that hello world. So if I run that, I'm just going to get the hello world that I had before. However, I created a one to run this file, and you can call it whatever you want. I can give it a name. But what I can do is I can actually choose the main class that it's executing. And then here's where I can put something on the command line. So what are you doing to me? Here is where I put something on the command line. So what I'm putting here is actually another book file that I downloaded. So if I want to run for using that one, then that will use this portion of the ternary operator, and it will see that there's something in the arguments array and use that. And how do I do it? If I make sure that I've selected that run from this dropdown. And now when I hit the green, we see that, okay, this particular one has 725 lines. And this is the book of something called A Modest Proposal by Jonathan Swift. If you haven't read Jonathan Swift, he was a bit clever. Oh, wait, but the main point is now, notice when I run it just from here, it uses the default because there's nothing on the command line. If I run it from using this, then it uses what the arguments are. Okay, so that's the 99% of the time, that's when I use the term ternary operator. Okay, moving on to the do or do while statement or do loop. This has the following syntax. So you start with do, and now you have to have curly braces because you have do, curly braces, while, condition, semicolon. Okay, so the whole thing is just one statement. So unlike the while statement, the while tests the condition at the top and then decides whether it wants to execute. The do while executes the statements first and then evaluates the condition. And like once it does that, everything is like the while. You keep executing the statement until the condition becomes false. And so you need to make sure, as with the while loop, that somewhere in here, you're changing that condition so that it becomes true, or it moves from true to false. Okay, so again, the logic is you first execute the statement, Then you evaluate the statement. If it's the condition at the end. If it's true, you execute the statement. If it's false, you keep going. So here's an example. So, and this could be done using a while or a do while. In many cases, it is sort of optional which one you use. In some cases, you want to make sure that you execute this block of statements at least once. In other words, in other situations, you want to make sure that if the condition does not hold, you just don't execute the statement. Okay, and they have kind of a cute example that has some gotchas in it, and that was this one called reversing the numbers. Okay, so the idea here is that it's going to take an integer from the user, and it's going to use some tricky manipulation to reverse the digits of the integer. Now, the book's example was a little bit, well, I'll show you what kind of went on with that. It turns out that let's kind of look at the algorithm. That's the main example of the do thing. So you want to execute it at least once. So what it does is the user has entered a number. So they've used some very clever integer operations. So if I have a number and I modulo it with 10, the result is the last digit of the number. Because when you divide by 10, the remainder is always going to be the last digit, period. So reverse, and this is going to be the final reverse thing, and that starts at 0. But now I'm going to take the incumbent reverse, multiply it by 10, and that just shifts every digit over to the left by 1, and then I add this last digit to it. And so what that will do is that will keep pushing each last digit over to the left. And then, but now to continue, I divide it by 10, and what that does is that it has the effect of lopping off the last digit using integer divide. Remember, integer divide is going to just simply truncate. And I do all that while number is bigger than 0. Okay, so let's see how they work. This is a very clever one. So let's say if I enter a number like 1, 2, 3, 4, it prints 4, 3, 2, 1. Now, one thing that I've modified with respect to the book's example is that I said the integer you enter must be less than this quantity. So I'm doing a Control or Command C on this. So when I run it again, just as a check, if I enter that value, then it indeed reverses it. But look what happens if I just increase that by 1. You say, well, it ought to work, right? Okay, what happened? Does anybody have an idea what happened?
There's no condition for if, like, returning a negative number?
Well,
you repeated the condition set.
Yeah, but it should have just reversed these numbers, though. Yeah, I could, it wanted a positive integer, but I entered a positive integer. This is a positive integer. So it should have worked, but what went wrong? what went wrong. And actually, I did post a video of how it went wrong that illustrated the use of the Netbeans Debugger. And this is a case where if you entered this number, and I actually discovered this when I was sort of playing with the books example, and I said, well, what would happen if you entered a really big number? I entered a really big number, and then I got back a negative. This has no relationship whatsoever to do with the number that I entered. Okay, what went wrong? Well, let's see, 40. Okay, so I tell you, I'll kind of duplicate what I was doing for on the video. There's a separate video that I posted and gave a link to in the lessons part, but I'll do it again. So the question came up yesterday about, okay, how can I step through this and see what the heck is going on? Okay, so with the Netbeans Debugger, what you do is you take one way is you want to set what's called a breakpoint. If you've used any debuggers before, that's basically how they work. In other words, I want to specify a place in the code where I want to stop. I can do that by moving my cursor into these line things, and I'm just left clicking. And when I left click, it outlines it in pink or salmon, however you want to do it. And that identifies that as a breakpoint. And I can see what breakpoints there are if I go Window, Debugging Breakpoints. And so in a large program, I may have a number of different breakpoints, and I want to maybe know where they are. And so I can identify them through this way. So how can I run this? Well, there are actually two ways, depending on if I'm running it from up here from the toolbar, it's this one, not the one to the right. But here I don't have a command set up there. But if I right click, and instead of saying run file, if I say debug file, then what will happen? Okay, so now notice it gives me variables. There's something called a call stack that's useful in larger programs. For here, that's not terribly useful, but here, so it sort of stopped here, but it's waiting for my input. So I want to give it my, this is the value that was causing the problem. So I need to hit enter, and now it runs, and now as you notice, it's green. And so my call stack, it identifies where I am. The call stack will also show me all the other steps that it took to get to this point. In this case, like I said, in this particular case, it's not terribly useful. But what is useful is this variables tab. And that shows me all the variables that are there. In fact, and that's one way of doing it. I can also hover over any variable. So now the number is the one that I entered. Reverse is starting out at 0. And then last digit is not, it says it's not a known variable because I haven't assigned it yet. So I've stopped right here. And I can, now up here in the toolbar, these different options show up. So one thing which is useful is the step over. So see this little arrow here? If I click that, it will advance to the next statement. Okay, so now my last digit is 3. And I can see that both here in the variables as well as by just hovering. Okay, so that it was correct there. Now it reverses 3, okay, because it was previously 0, multiplied it by 10, it was still 0, added last digit 3. Okay, so far everything is fine. And now number, divide by 10, notice it just lopped off the 3. Okay, so that's working as needed. Now I can step And now the last digit is 1. Okay, so that's correct. So everything is working fine. Now, what I can also do is, you see this little green arrow here, or F5, if you would like to use those. If I hit this, it will actually move to the next breakpoint, wherever that is. Okay, so everything is going fine here. Now, another option is if let's say I just wanted to run down to here. I put the cursor there, and then this is run to cursor. That'll run to wherever the cursor is. Okay, so everything is working fine here. So if we just kind of keep looking at the variables tab, we see that as we execute each step of this, it's doing everything perfectly so far. Okay, so where did it go wrong? All right, so at this point, see, we've created this number called reverse, and it is perfect so far. So something, okay, it picked off the last digit. The last digit was 2. That's correct. What happened? It was on this statement right here that reverse went from being correct to that negative number. Okay, so then number's bigger than 0. And as far as the code goes, it said, hey, the condition was met. We're all done. And if I just sort of hit this continue, then everything is kind of going there. Okay, do you now see what went wrong? It was on this statement here. Okay, so what could have possibly gone wrong? Well, I added a number that generally shouldn't be too bad, but I took this number and multiplied it by 10. That's my suspect. And that's indeed what happened. What happened, remember that we talked about the range of possible values that an int variable can take. So what happened was, for this value, by the time it got to this much in reverse, when it multiplied it by 10, right here, it overflowed the int variable. And when an int variable overflows, what that means is it took it into a territory where instead of representing positive numbers, it was representing negative numbers. In other words, that negative value was what happened when you try to execute an operation on an int that takes you above the maximum value. So that was the gotcha on that. So that's why that's something you should be aware of. Okay, so the books didn't do that. So in the book, if you kind of execute that, then it wasn't presenting it. Okay, so now again, the difference, the while loop is we evaluate the condition at the beginning. If it's false to begin with, then we keep going. Only if it's true to begin with do we execute the statement. The do, we always execute the statement at least once and then evaluate the condition. And the other lesson to take away is that be really careful when you're doing operations on integers, because you could get really unintended results, especially if you're making assumptions about what the possible values are. Now, one of the things that the integer object gives you, I kind of skipped over this a little bit, was this is something called a max value. And just through playing around, it turned out that the largest integer that this algorithm could handle was the max value minus 235. But the thing to understand, that's what this value was. And so as soon as they stepped over that by 1, then it just blew up. Why? Because, again, this operation caused integer to overflow. Okay, so now moving on, what we're going to do is we're going to, I want you to finish section 6.4. That's our final control of flows, the for loop. You've probably encountered it in previous languages, but we'll show you how Java does it, which is basically the way C did it. Java kind of took it from C. We're going to jump over chapter 7. We're going to come back to chapter 7 later in the course, but we're going to jump over and start on chapter 8, which is about arrays. Now, you've all know about arrays, but this is how Java does arrays. It is a little bit different than what you may be used to, because arrays in Python and JavaScript are more like array lists in Java, because you can put stuff in and take stuff out willy-nilly, and it'll expand to do that. Java's arrays are much more OCD, as we will see tomorrow.